And welcome to tonight's program for Exploring the Night Sky. I'm Dana Whitelaw, the Executive Director at the High Desert Museum, and I'm so glad that you've joined us this evening. Before I introduce Dr. Sayle and tell you about her super interesting background and her job, I'm going to mention a few things about our program logistics. Our audience members are muted just to help decrease with background noise, but please stay vocal and engaged in the chat. If you have a comment or a question, please put those in the chat and we'll have time for Q&A at the end of the program. And we are definitely in for a treat tonight. Our presenter this evening is Dr. Amy Sayle. And Dr. Sayle is a former epidemiologist who's now an informal science educator at Morehead Planetarium and Science Center at the University of North Carolina at Chapel Hill. And I love that conversion from epidemiology to science education, definitely. Dr. Sayle communicates astronomy to the public and tells stories about the stars under the planetarium sky, sky watching events on night paddles, and is a longtime volunteer at Bryce Canyon National Park's annual astronomy festival. She's also the founder and coordinator of the North Carolina Science Festival's annual statewide star party, which partners with museums, parks, libraries, and astronomy clubs from the North Carolina mountains all the way to the coast every April. I definitely think we need one of those here in Oregon. Amy holds a Ph.D. in epidemiology from UNC Chapel Hill and is a proud winner of the Bold-Faced Liars Showdown in Laurinburg, North Carolina. And she won for a tall tale about accidentally piloting a planetarium full of fourth graders into outer space. So maybe we'll hear more about that later. Amy is originally from Seattle and a huge fan of Central Oregon. And Amy, a big virtual welcome back to the West, and I'll pass it over to you.
Thank you so much, Dana. And also want to thank Louise and Becca and Kyle from the High Desert Museum. So I live in North Carolina, but I have family in Bend and have had the pleasure of visiting the museum several times. I am particularly in love with the otters. So tonight I'm going to be sharing stories and science of the night sky. A heads up, there is going to be an interactive component near the end that you will not want to miss. So stay awake out there, and because I hope you'll participate. I'm going to share my screen in a few minutes and show you pretty pictures of the night sky, but I want to start right off with sharing one of my favorite star stories. So this is a story that is told throughout Asia. There are many versions and variants. I'm going to tell you one particular Chinese version that I like. It's the tale of the Weaver Princess. And this is how it goes. A long time ago, in a village in China, there lived a young man with his water buffalo. Every day they would work the fields. Every night they would go to the river. The buffalo would play in the water. The young man would lie on the riverbank and play his bamboo flute. One night, the music of this flute traveled up and up and up, all the way to the heavens. This is where the Queen Mother, the King Father, and the Weaver Princess lived. The Weaver Princess, her job was to sit at the heavenly loom and weave colorful silks that she would drape across the clouds to dry. And on this one evening, she heard the music of the bamboo flute and she was curious and she hopped down, 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 all the way to the ground. She met the young man, they talked, they sang, and they fell madly in love. And they were very happy together. Time went by, the buffalo grew old and sick, and it said to the young man, "When I am gone, you must sew my hide into a cloak. The cloak will perform a miracle for you." Well, soon he needed a miracle because the Queen Mother walked by the heavenly loom and realized it had gotten rather dusty. She hadn't seen her daughter in a very long time. The heavenly guards were sent down to earth and they pulled the Weaver Princess back up into the sky where she just watered the heavenly gardens with her tears because she had been separated from her lover. Every night, the young man looked up at the sky and tried to get a glimpse of the Weaver Princess. And then he remembered the buffalo cloak. He put it on and a miracle happened. He was lifted up off the ground as if by magic, up, up, up. And soon he could see the heavenly loom. He could see the Weaver Princess rushing out to greet him with a big smile on her face. And he could see behind her the Queen Mother watching. She pulled a silver pin out of her hair and she drew a silver river across the sky. And then she took the young man and turned him into a star, Altair, on one side of the silver river, took her own daughter, the Weaver Princess, turned her into a star, Vega, on the other side of the Silver River, and there they were, separated. But the king father took pity on the young couple, and he decreed that once a year, on the 7th day of the 7th month, the magpies of the heavens would be allowed to form a bridge across the Silver River, and the Weaver Princess could cross and hang out with her young man for one day. And on that day, there is to be a big feast in China to celebrate the couple. I have been told it's Chinese Valentine's Day. If there is a rainbow that day, obviously it's the Weaver Princess. In her haste to get to her young man, she has strewn her colorful silks across the sky. And that night, if it rains, it is the Weaver Princess crying because she has to return to the other side of the Silver River for a whole nother year. Okay, I think a lot of us can relate right now to the concept of being separated from a loved one for a year. I want to share my screen now and show you the stars that I'm talking about and give you an idea of what the Silver River is in the sky. You may already have a guess, but let's see. Okay, so the Silver River refers to the Milky Way, that hazy band of light that you see in a dark sky that represents the plane of the galaxy that we live in. Now I get a little overwhelmed when I see this many stars, but I'm pretty sure I got them labeled correctly. Vega is the Weaver Princess. Altair is her young man. And I want to mention something about this story. It comes with a little bit of a scientific epilogue. I don't want to leave you with the impression that at any time of the year, Vega takes a jog across the Milky Way and hangs out with Altair. Everything's moving. The stars are moving, but they are so far away from us that for the most part, they don't appear to move relative to one another over short periods of time, like a human lifetime, or even many human lifetimes. So the people who first told this story at least 2,000 years ago, they saw the same star patterns that you can see tonight. We are connected to our ancestors through the night sky and the stories we tell about it. The sky is our natural heritage, and it is our cultural heritage. Okay, so that brings us to our theme tonight, connecting with the universe through science and stories. And I want to talk about how you can connect to the universe, both in an intellectual way and emotionally, like in a story kind of way. So I want to mention one way you can do this. For those of you that live in Oregon, you can go to the High Desert Museum and see the new exhibit, Cosmic Microscapes. This is a meteorite photography exhibit. So you can have an intellectual science experience. Meteorites are space rocks that can tell us something about the origin and evolution of the solar system we live in. And you can also have an emotional experience through connecting with the universe through the beauty of our own solar system. All right. So, back to our night sky, because this is going to be an additional way you can connect with the universe, is through observing the night sky and learning something about the science and stories that it has to share with us. So when you look into the sky, it is half your field of view. You are looking into the universe on a clear night. And as my colleague and co-founder of the North Carolina Statewide Star Party likes to say, we should make friends with the sky. And that's Mickey Jo Sorrell, and I think she's on tonight as well. So I'd like to know, if you haven't already put into the chat, I would like to know where you are watching from. So if you haven't already told us in the chat where you're watching from, if you can go ahead and just add that. And I know from the list of registrations that many of you are in Oregon, but some of you are elsewhere on the West Coast, Washington State, California. There's at least one person from Colorado, somebody from Florida, several people from North Carolina and Massachusetts as well. And I want to know what sky you're looking at tonight, because it matters in terms of what sky you get to see. So there are three main factors that determine what sky you see. There's the date. In other words, where Earth is in its orbit around the sun. There's the time, which has to do with what side of the galaxy your part of Earth is pointing to. And then there's your location. Your latitude specifically is what matters. Longitude is less important than you might think. So for the person watching from Brookline, Massachusetts at 42 degrees north latitude, you will see the same sky at a different time because of the different time zone, but you'll see roughly the same sky as somebody in Bend, Oregon, latitude 44 degrees north, because it's roughly the same latitude. I get to see the same sky as somebody in northern Arizona. I know we have at least one person watching from Arizona. Again, because the latitudes are similar, even though the longitudes are different. Okay, so let me just tell you a little bit about where I get to talk about astronomy at. As Dana originally mentioned, I started out my career as an epidemiologist, researching epi, teaching epi, then teaching writing about epi, and then teaching writing about science, and then just teaching science to the public with a focus on astronomy. And I get to do that at Morehead Planetarium and Science Center, which is an old planetarium we opened back in 1949. We were the first planetarium in the world on a college campus. We're part of the University of North Carolina at Chapel Hill. And I'm going to be showing you the night sky using a planetarium software called Stellarium. It is free open source software that you can download for your own device if you're interested. There's also a web-based version if you don't like to download things. And the website is stellarium.org if that's of interest to you. I am not going to drive the software live tonight. That is a little more multitasking than I can handle. So I have taken screenshots instead. So this is a screenshot. This is the sky as it will look after this program ends for Bend, Oregon. This is a 7:30 p.m. sky tonight, March 12th, 2021. And you can see from the red letters that you will not see on the real horizon that we have a view looking north. Your mileage may vary slightly if you're watching this from a different location, but this is, I think for just about everybody watching, this is roughly your sky an hour and a half after sunset. So sorry, North Carolinians, Bostonians, Floridians, the sky has moved on since it's a little bit later here for us, but you can see it tomorrow night too if it's clear. Okay, so I mentioned that the sky you get to see depends on your north-south location on Earth, your latitude. It depends on the time and the date. So this means the sky provides you with a compass, a clock, and a calendar. And I want to explain what I mean by that and also share some stories along the way. Okay, so what we're going to do is we're going to first explore how the sky is like a compass. So you may already know that because of Earth's rotation, we rotate west to east. This generally makes things appear to move in the sky from east to west. So that's why the sun, the moon, stars other than the sun, planets generally rise more or less in the east, set more or less in the west. But if you're out at night, you've lost the sun, and you want to just use the nighttime stars to figure out direction, there's one star in particular that can really help you out, and that's the North Star. The North Star is not the brightest star in the sky. That's a common misconception about it. It's not famous for being bright. It's famous for being in the north. So you need a method to find it because it's not obvious which one it is. And there's a couple of methods that I like to use. They both work pretty equally well in the early evening this time of year. The first is the Big Dipper method. So look around your screen right now and see if you can play connect the dots with 7 of the bright stars and find something that looks like a Big Dipper. And I'll give you a hint, it's in the northeast right now. See if you can find it, and I'm going to help you out. So 1, 2, 3 stars in the handle, 1, 2, 3, 4 stars in the bowl. None of these stars is the North Star, but 2 of them, these 2 are the pointer stars. They point to the North Star. And the distance you want to go is about the length of the dipper, but you want to start at the bottom of the bowl, go through the top, keep going until you hit a moderately bright star. This is Polaris, the North Star. It is almost directly over Earth's North Pole. So it's over our planet's axis of rotation. It's going to stay in the north, and it acts like a pivot point in the sky. So if you've never found the North Star, those of you in Oregon, it looks like your entire state is going to be clear this evening, clear skies. So go out after this program, see if you can find the Big Dipper, and then see if you can point your way to the North Star. And while you're there, if you have a decently dark sky, you may notice that Polaris, the North Star, is the tip of the handle of the Little Dipper. So the handle is curving like this, and then there's a bowl right here. Now, for those of us in the Research Triangle area in North Carolina, we've got a lot of light pollution, so we're going to be lucky to see these 2 bright ones right here, and then the North Star itself. Let me give you another idea. This is something you will not see in the real sky, but this will help you out. So the Big Dipper and the Little Dipper are not so-called official constellations, but they are part of official constellations, as recognized by the International Astronomical Union. Those are the people who demoted Pluto, by the way. The Big Dipper is part of Ursa Major, the big bear, which is a funny-looking bear. It's got this really long tail. This was Zeus's fault. And then the Little Dipper is part of an extremely cute bear, Ursa Minor, the little bear. So this is how the sky is like a compass. You can use like sunrise and sunset to tell east and west. You can use the North Star to tell you north. Once you've got one direction, you've got them all. But the sky is also like a clock. And this has to do with the sky's motion over the day and over the night. So Earth rotates every day. It takes 24 hours for Earth to rotate. And Earth's rotation or spin is what makes the sky appear to turn around us every 24 hours like a clock. So earlier I said things rise in the east and set in the west, but really it's a little more complicated when you have this view to the north. Things in a sense don't really rise or set because remember, Polaris is the pivot point around which everything turns. So in a moment, I'm going to show you a photograph, a long exposure photograph of the northern sky. And I want to see if you can find the North Star in this photograph. And I want you to predict right now in your own minds, what is this photograph going to look like? A long exposure photograph of the northern sky. Okay, get ready. This is going to be taken from North Carolina. So you will actually see the North Star might look like it's a little lower relative to the horizon, but it's actually still in the north. Okay, so what you see when you look north is you see circumpolar stars and constellations. The stars don't truly rise or set. They get lower, they get higher, they get lower again. And so my guess is probably that one is the North Star, the one that's barely moved right there. So the sky is not just like a compass, it's like a clock as well, always turning around us because of Earth's rotation. Okay, I want to show you another way to find the North Star though, because at certain times of night and certain times of the year, the Big Dipper will be very low on the horizon because it's turning around like that. And especially in places where there are a lot of trees, like where I live, if the Big Dipper is down here, you can pretty much forget seeing it. First of all, you might have some sky glow from light pollution, but also there's almost certain to be a big tree right here. Okay, so if the Big Dipper is low, there's another pattern that will be high, and that is Cassiopeia. So if you already know her, she's probably jumping out to you on your screen. But if you don't, you're going to play connect the dots with the stars and see if you can find a kind of a sloppy letter W. And she is in the northwest as a hint. And the W is kind of on its side. See if you can find a W in here. 1, 2, 3, 4, 5. And somehow out of this, you're supposed to get a queen reclining on her throne. You'll notice she's holding something. That is her mirror. She is admiring her great beauty. There's a number of stories about this. The Greek myth version of this I like a lot is that Cassiopeia, the queen, bragged that she was so beautiful. Her beauty surpassed that of the sea nymphs. Well, it's never a good idea to brag on these stories. So Poseidon, the god of the sea, sent the sea monster Cetus to ravage the shores of Cassiopeia's kingdom. Very big problem. The sea monster leap out of the waves, gobble up anybody who was walking by. Now her husband, and apologies, I don't have a picture for him, but try to imagine Cepheus as sort of a house. So here's the roof of the house, and here's the base of the house. He's a house in disrepair. Here's a gutter that fell off. Here's some siding that fell off. So King Cepheus consulted an oracle. What am I supposed to do about this sea monster? The answer he got back was one choice. You will have to sacrifice your daughter, the Princess Andromeda, to the sea monster. Well, he didn't want to do this, of course, but he felt like he had no choice. So Princess Andromeda was led out to the seashore and chained to the rocks, wearing nothing but diamonds in her black hair, emeralds around her wrists, rubies on her ankles, and left there for the sea monster. Well, this is when Perseus, our hero, came along. Perseus had just slain Medusa, the one that if you look at her, you instantly turn to stone. He had found this clever way of just looking at her reflected image, managed to chop her head off, and then kind of took to carrying her head around in this magical bag because, you know, you'll never know when you need the head of Medusa. So he came upon this scene that was unfolding, and he made several astute observations. Number one, girl. 2, beautiful. She took after her mom in terms of looks. 3, not wearing anything except for a lot of really expensive jewelry. He realized he was in love. So he flew over to Cassiopeia and Cepheus and said, I'll make you a deal. Give me your daughter's hand in marriage. I'll take care of the sea monster. Well, they thought that sounded great. Never mind that Andromeda had been promised to someone else. And so Perseus went over to Andromeda and yelled at her, "Shut your eyes," because here was Cetus leaping out of the water at them. But Perseus had that head of Medusa ready, showed it to Cetus, who instantly turned to stone and sank. And then Perseus and Andromeda were wed in this wonderful celebration that did have a flaw, as all weddings tend to have. This was a big one. The ex-fiance showed up with his big mean buddies, and they had weapons, and things were looking very grim until Perseus remembered he had taken to carrying the head of Medusa with him everywhere. So he took care of them. There is an epilogue to this story, a science epilogue. And remember Cassiopeia's position in the sky. She got punished even further for vanity, as if the sea monster wasn't bad enough. She got punished with this circumpolar position in the sky. So she is close enough to the North Star. Let me show you how she points to it. So she's like a letter W. In the middle of the W is like an arrow that points to Polaris, the North Star. She's close enough to the North Star that she is one of these constellations for pretty much every latitude of the people watching, as well as the people who originally told this story. She is circumpolar. Half the time, she is upright on her throne, very dignified. The other half of the time, well, she spends 12 hours out of every 24 upside down, clinging for her life, robes around her ears. So she probably needs some privacy right about now. Okay, so the sky is a compass, it's a clock, and it's a calendar. And what I mean by that is because of Earth's orbit around the sun, we see certain constellations better at certain times of the year. So here in North Carolina, it was nearly 80 degrees today in Chapel Hill. It feels like spring or summer, but it's technically still winter. We are still seeing winter constellations dominating the evening sky. So Orion is a winter constellation. See if you can find him. If you know him, again, he's probably jumped out to you. If you don't, look for Orion's belt. That's the easiest part to find. 3 stars right in a row. And he's fairly high in the south-southwest. So now we're looking at a southern view, 7:30 p.m., roughly an hour and a half after sunset. Okay, so here's Orion. Here's Orion's belt. He's got a sword hanging from the belt. He's got 2 shoulders. That bright reddish one is Betelgeuse. He's got 2 knees or feet. That's Rigel. And he's got, I see a bear skin or a shield, tiny head, and then like a club that way. You don't have to imagine him like that if you don't want to. Here's what Stellarium decided to draw for him. And there's a story that explains why he's a winter constellation. And this is another Greek myth. And this is how it goes. Orion, the mighty hunter, bragged that he was such a great hunter, no beast on earth could escape him. Now remember, bragging never goes well in these stories. So that was asking for it. So the god sent a tiny scorpion to prove him wrong. And that scorpion stung Orion on the heel fatally. But before Orion died, he got his revenge. He clubbed the scorpion to death, double homicide. And then the gods placed the enemies on opposite sides of the sky so they'd never see each other again. And that, according to Greek myth, is why you see Orion best in the winter, but the scorpion best in the summer. And there is a scorpion constellation. It's called Scorpius. And if you want to see Scorpius tonight at the end of winter, assuming you're watching this live, you're going to have to stay up really late or get up really early. So we're going to keep our southern view, but I'm going to take you forward nearly 10 hours. We're going to lose Orion, but we will get the scorpion. And the scientific explanation of why you see different constellations, if you just think about Earth orbiting the sun, it takes a year for Earth to orbit or go all the way around the sun. That's the definition of a year. The nighttime side of Earth, the side pointed away from the sun, every night we point to a slightly different part of the Milky Way galaxy. So the stars rise and set on average 4 minutes earlier every night. So as the nights go on, the weeks, the months, the seasons, you will see different constellations better in the sky. Okay, so that's how the sky is like a calendar. Okay, let's go back to this southern, because I'm really, really hoping that you all will make friends with the sky tonight if it's clear where you are. In Oregon, you have no excuse. I know it's clear where you are. That you'll go out. You'll have to bundle up though, but go out and that you'll try to find some of these things. So let's just find a few more things while we're here. So let's go to Orion's belt and let's do something called star hopping. So we already know how to find the belt. Let's hop our way, head down and to the left to the brightest star in the night sky. Stellarium likes to mark bright stars with big dots. This is Sirius, the Dog Star. And right there, It's part of Canis Major, the big dog. And then if you go up and to the right, you'll get to an orangish star called Aldebaran. Don't confuse it for Mars. Mars is hanging out in this part of the sky right now. Planets move, but this is where it's hanging out right now. And here's how you're going to keep track, because they look kind of similar. They're both pretty bright. They're both kind of orangish reddish. All you have to remember to keep them straight is that it goes twinkle, twinkle, little star. So Aldebaran is a star. It will look like it's twinkling, and Mars is a planet. It will probably look like it's shining steadily. And if anyone wants to know more about that, we can talk about that in the Q&A. Okay, so let's just find a few more things while we're here, because there's some really interesting things in the sky. So Aldebaran is the eye of Taurus the bull. It's got this V-shaped snout, and then a really long horn that way, and then a really long horn that way, and then kind of the whole bull thing falls apart. This little part of the V, not Aldebaran, but the rest of it, these stars not only look like they're close together, they actually are close together. So usually when you see stars like that look like they're a group, like a constellation, they're not actually, usually. Constellations are made up human inventions. They are completely arbitrary. So it's just the human brain. We love to make patterns out of things, even when they don't exist. So these stars in Orion, for example, they are not at all the same. They lie at all different distances. So they're not necessarily gravitationally associated. They're not necessarily born out of the same cloud of dust and gas and so on. But these stars are. This is the Hyades star cluster. And your eye might have been caught by this little cluster here. That's the Pleiades star cluster. It goes by many different names. The Pleiades, also known as the Seven Sisters. In Japan, it's Subaru. Check the emblem on a car sometime if you want to see why. Also known in Onondaga culture as Ukwara, the Seven Star Dancers, and to Western Mono, 6 young women. And there's also the 6 young men. And the story that I really love about this, so this is told by people native to Central California, for you Californians watching out there, is that these 6 young women would go out every day and pick plants to eat. And then the men would go out, their husbands would go out and hunt for animals. Well, one day the women discovered a new plant, wild onions. Oh, they were tasty. They ate and ate and ate, and they were so excited to share the wild onions with their men. And the men came home from the hunt, and they were repulsed by their wives' breath. So they made them sleep outside the huts that night. And this went on for 6 days, until finally the men said to the women, "We don't want you anymore." And so the women took their magic eagle down ropes, they sang a magical song, and they went into the sky. Well, when the men saw the women leaving, they regretted what they had done. They realized they would be sad and lonely without their wives. So they too sang a magical song, and they went into the sky, and they tried to chase after their women. But the women consulted with each other and said they didn't want us anymore. And so they called out to the men, "Stop." And because the women's magic was more powerful than the men's, the men had to stop. And so you can see them tonight. If you go out in the early evening over there, kind of in the southwest, you'll see the 6 young men chasing their wives across the sky eternally, and they will never catch up. And in fact, they really are many light years away from each other. They really will never catch up. I want to zoom in a little bit on a image of the Pleiades, just so you can see it's actually a lot more stars than 6 or 7. And then for the North Carolinians watching, I wanted you to see this, the city flag for Durham, North Carolina, which is down the road from me. I used to teach at Duke, so I feel an affinity with Durham. You'll notice the stars on the city flag. They are a representation of the Pleiades, and it was a really good choice for the Durham flag because Durham is nicknamed the Bull City, and the Pleiades star cluster is within Taurus the Bull. So nice choice. All right, so we've talked about how the sky is like a compass, a clock, and a calendar. I want to talk about how the sky is like a time machine. And I mean this in a very literal sense, not metaphorical. To tell you this story that is going to illustrate how the sky is like a time machine, we have to find a particular star, Arcturus. So I've switched our view again. We're now looking east. So this is where we're going to see things rising. And I had to keep us up a little bit later, Bend, Oregon. It's now 8:30 p.m. So those of us on the East Coast, as soon as this is over, you can run outside and look for it now because it's already in the sky. Arcturus has already risen. Those on the West Coast, you're gonna have to wait a little bit longer. But see if you can find Arcturus. It just rose in the east in this version of 8:30 p.m. sky for Bend. And Stellarium lights to mark bright stars with big dots. And also you can use the Big Dipper to help you find it. So before we used the side of the bowl to get to Polaris, the North Star. Now we are going to use the handle. Notice that the handle is curved. Think of another word for curve, arc. You are going to arc off the handle to Arcturus. And it is an orangish star. It is the brightest star in the summer sky, by the way. The brightest star in the night sky right now in March is Sirius, the Dog Star. We saw that earlier. It's near Orion. Orion's belt points to it. But this is once Sirius has kind of gone away from our view, Earth has moved in its orbit, and the calendar's moved on, Arcturus will be the brightest star you'll see in the evening sky. And because of that, that means that when it gets closer to summer, it'll be the first star that pops out. And so it always makes me think of that nursery rhyme. Starlight, star bright, the first star I see tonight. I wish I may, I wish I might have the wish I wish tonight. Okay, so I'm hoping you're gonna go out tonight and wish on Arcturus. And when you do, please think of this story. This is a true story. This is a science story. Illustrates how the sky is like a time machine and we have to go back in time just to tell it. Because the story takes place in the year 1933 in the city of Chicago. Chicago was hosting a World's Fair that year. It was the second time Chicago had had the honor of hosting a World's Fair. The opening night was May 27th, 1933. It was 9:15 p.m. Central Time, and there were thousands of people gathered on the shores of Lake Michigan in the dark, awaiting all the lights to come on to start the opening night ceremony. And what happened was that 4 telescopes in 4 different US states, none of them in Chicago, by the way, were aimed at this star, Arcturus. The light from that star was allowed to collect through the telescopes onto photocells. This was new technology in 1933. Photocells can take light, turn it into a form of electrical energy. They then amplified that energy and sent it to Chicago via telegraph. That then resulted in a switch being flipped, which flipped some other switches, which activated the entire outdoor lighting system for the Chicago World's Fair of 1933. Okay, so what does this have to do with time machine? It has to do with why they picked Arcturus for the big honor. Astronomers thought that the star was 40 light years away. So a light year, it sounds like a unit of time, but it's really a unit of distance. 1 light year is the distance that light travels in a year. So think about that for a minute. Light travels really fast, fastest thing in the universe, 186,000 miles a second. So in 1 year, light covers a lot of ground, or a lot of space, I should say, almost 6 trillion miles, or about 10 trillion kilometers. So 40 light years away, that means Arcturus is so many trillions of miles away that even traveling at the speed of light, that starlight hitting Earth on May 27th, 1933, and having all those effects opening the World's Fair, that light left Arcturus 40 years earlier in 1893. And the significance of that year is that it's the first time Chicago hosted a World's Fair. There's an epilogue to this story, which is they chose the wrong star. Arcturus isn't 40 light years away. It's actually just under 37 light years away. Let's just round to 37 for simplicity. So being 37 light years away, what that means is when you go outside tonight, which I hope you will, and you make your wish on Arcturus, you are wishing on 37-year-old starlight. You are seeing Arcturus not as it looks tonight in 2021. You're seeing it as it looked when the light left it in 1984. In a very real sense, when you look at Arcturus this year, you are looking at the year 1984. So if you were alive then, you might think about what you were doing at that time. The sky is a time machine. Everything you are seeing in the sky, you see as it looked when the light left it in the past. So another way of thinking about this, if there's anybody watching who is 37 years old right now, Arcturus is your birthday star. The light that you see tonight is as old as you are. It left the star around the time you were born. So let me show you some other birthday stars, just in case you're not 37. We're going to swing south and we're going to go back to 7:30 for this one. So I'm showing you Orion, and let me show you some of the bright stars in the vicinity. So if there's any kids watching, you get to claim Sirius if you're 9 years old. This is your birthday star. You can also claim it if you're 8, by the way, because Sirius is really about 8.5 light years away, so 8 or 9. Procyon, 11. If you're more middle-aged, you can maybe claim Pollux or Castor. Capella, I think I've lost off the top of the screen, but it's 42, 43 light years away. If you just qualified for Medicare, so did Starlight from Aldebaran. That's 65 light years away. And if you're 79, Regulus is your birthday star. And if you're wondering, hey, what about these? Well, they're really far away. So I know that these two bright stars are not your birthday star. So the sky is a time machine. All right. So I've been sharing with you some science and stories of the night sky, but I have been presenting planetarium programs long enough that I am absolutely convinced everybody has a night sky story. And what I mean by that is that you have a story, some sort of memory that you have formed underneath a night sky. It could be something big, it could be something small. And I'm going to ask you to share that story in a breakout room in a few minutes. And if you're sweating right now thinking, oh no, I can't think of anything, don't worry. I'm going to jog your memory. Here we go. Okay, first of all, I'm going to be showing you some photos, and I have to give you a disclaimer, which is all the photos with people were taken pre-COVID. So don't be alarmed when you see people crowded together with no masks. All right, so maybe you have a story, a memory that involves seeing the Milky Way, that hazy band of starlight that represents the plane of our galaxy. Maybe you remember the first time you ever looked through binoculars or a telescope, maybe with a family member, or maybe with friends. Maybe you remember the first time you looked through a telescope and you saw the planet Saturn and realized, hey, that thing really does exist and it really does have rings. Maybe you have a memory, if you're old enough, you have a memory of looking at the moon when somebody was walking on it. Or maybe you've waved hello to people in outer space. The International Space Station is going by every 90 minutes, orbiting Earth, and sometimes those passes are visible to us. It looks like a bright white moving star. Maybe you've seen a meteor or a shooting star. Maybe you've seen an entire meteor shower, like the Perseids in August or the Geminids in December. Maybe you've seen a comet. This is Comet Neowise from last year, as photographed from Hillsborough, North Carolina, I think. Maybe you've been to a National Park Service unit. The National Park Service considers the night sky a natural resource worthy of protection, just like the land, the water, and the air. Maybe you've done some sort of educational activity under a night sky. This is one of the statewide star party pictures from a few years ago. Maybe you've been to the Observatory if you live in Bend, or to Sun River Nature Center, an observatory which has fantastic astronomy programs. Maybe you've been to Pine Mountain. This is me freezing to death, even though it was summertime. Maybe you've seen a lunar eclipse. You've seen the full moon pass into Earth's shadow. Maybe you remember the 2017 solar eclipse. This is Morehead Planetarium, where I work in Chapel Hill. The eclipse was only 93% max at our location, and still 4,500 people showed up. And they only saw a partial eclipse, but it was still really exciting. Show you a couple pictures of that, but I'm guessing a lot of you actually saw the total solar eclipse, especially those of you in Bend, because you were so close to the path of totality. So this isn't technically a night sky story because it happens during the daytime, but we're going to count it. I'm going to tell you my story as a way to help you think about your own. This is my stepsister, Emily, holding the North Carolina Science Festival spokespot, Kelvin, and we are in a traffic jam for science. This is Madras, Oregon. We're here with my cousin Kate. This is shortly before totality. And those of you that know Oregon, see if you can spot the mountain in the picture. I know it doesn't look impressive in the picture, but it's way more impressive in real life. And our memory of what happened is that we heard this roar behind us. And what had happened was that thousands of people had suddenly seen Mount Jefferson disappear, swallowed up by the moon's shadow. And then the shadow raced across, covered us up, and turned day into night, and created a memory and a story that we will tell the rest of our lives. Okay, so I'm convinced everyone has a night sky story. You get to count the eclipse if you want. And we're going to send you into breakout rooms shortly so that you can share what yours is. And by the way, it doesn't have to be something big. It can be something really simple. Just some last time you were outside and you noticed the moon or something. Hello, welcome to those coming back. Hope you all had good discussions in your groups. I see some nodding. Okay, they're coming back.
We'll give it another minute or so.
Okay. There might be a room or two, or we may have lost some people. Hopefully not. Hello, hello. I see Emily. Hello. Oh, this is really fun to see faces.
It is great to see faces. Welcome back, everybody.
Okay, I think
this.
Yeah.
Yeah, I think we're good. Well, we have about 10 minutes left, and I have some questions for Amy. If you have any questions, feel free to put them in the chat. And why don't I get started with a question? And if anybody wants to share their night sky story, maybe if you know how to raise your hand in Zoom, I could identify you that way if you want to share. Oh.
Or can they put into chat if they want to share?
That would be great. If anybody wants to. Oh, here we go. Hey, Linda Paznokis, do you want to share your star story? You're still muted. There you go.
This is a different one I thought about after we did our sharing, based on something that was said earlier about the constellations just being, human creations. When I was teaching elementary school, I used to give my students a paper that had just a drawing of the stars on it, and then had them create their own constellations. And that was really fun for them then to go out and see, could they actually put together a constellation that they had created themselves. That was just kind of fun.
I love that.
Okay. And yeah, Amy, do you want to call on people? Go ahead.
Can we call on MacBook Pro, otherwise known as Emily?
Hello, yes, I am Emily. And I have a question that I'm hoping you can answer. So my story that I remembered was I was on the beach in South Carolina, so facing east, and my friend and I were walking on the beach shortly after sunset, and we saw a light coming up over the ocean that was so huge and like so big, we had no idea what it was. And it turned out to be the moon. And I remember we were just astounded because we were, well, what is this thing? So when we see that big moon, and this was the biggest moon I've ever seen, yes, what makes it look so big?
So what's really weird is nobody actually knows for sure, but it is a real illusion. It's called the moon illusion. And it just looks, to most people, your brain tricks you into thinking it looks really huge near the horizon. And but if you tried like covering it up, with your finger, stretching your arm all the way out, you would have been able to cover it up just the same when it was at the horizon than when it was overhead. So it's your brain playing tricks on you. I've been afraid to try this in public, but I have heard you can break the moon illusion by mooning the moon, bending down and putting your head between your legs, looking at it that way. If anybody tries that, report back, please. Thank you for that question.
Well, I have a story, and our night sky story was that we were camping on the sand, and we were looking up at the night sky.
And?
That sounds like it was beautiful and a meaningful experience. Thank you for sharing that. I'm guessing many stories involve camping in particular.
Let's do one more night sky story and then a couple of questions. How about Rachel?
Okay, go ahead and ask. Who wants to ask? Warner, go ahead and ask. Okay. Ask your question.
How many rings does Saturn have?
Ooh, that's an interesting question. I don't know if I know the answer to that because it's kind of hard to know what to count. Because the rings, they look like they're solid from far away, like when you look through a telescope. But if you were to get really close to Saturn, you would see that they're actually individual particles, ice mostly. Yeah. Yeah, great question. Thank you.
How much stars are in the sky?
Whoa, that's a deep question. How many stars in the sky? Okay, so there's a lot of levels you can answer that question at. One is how many stars can you see at any one time? Maybe a couple thousand if you're lucky, if you have a nice dark sky. How many stars are in the Milky Way galaxy that we live in? Something like 200 billion. How many stars there in the universe? Trillions and trillions and trillions. Yeah, that's a great question. Thank you. Okay.
Joshua, do you have a story or a question?
Oh, I mean, I was just going to tell a story that I told my breakout group. But so I was trying to take a picture of the eclipse from Portland, Oregon, or 2017, and I had attempted, because I know that there exist these filters particularly for solar imaging, which I didn't go ahead and buy. I thought, when am I ever going to use this again? And so I attempted a technique where, which I had read about from amateurs, whereby you take polarizing filters, which I have several of, and you put 90 degrees on them. Of course, it goes all black, and you sort of try to reduce the angle slightly. And so you do let some light through. And I thought that'll work just fine for me. That doesn't work at all. The camera was not able to focus. I have about 320 megapixel photos of just blurry shadows. I sat out there on my porch all day, clear view of the sun. I took meetings online with my laptop as I'm like really focusing on, because the sun moves across the sky. I was really trying to track on my tripod to get the perfect photo, but not a single one turned out. And so next eclipse, I'm buying the right filter because it's worth it. If I'm really going to put hours into photographing that phenomena, get the right filter. That opposing polarizers does not work for that type of photography task. Yeah.
Thank you for talking about the solar eclipse, because I wanted to mention that the next one is coming up for the US, the next total solar eclipse. It's only 3 years from now. So mark your calendar, April 8th, 2024. Now, for those of you in Bend, you got spoiled because like all you had to do is basically like barely pop over, to Redmond or something. You're gonna have to go farther this time. So April 8th, 2024, the path of the total solar eclipse will go through Mexico, and then it'll cut a different path through the US. It'll actually go up through Texas and right through some major cities, and then kind of trace a path through Ohio and then kind of out Maine or so. You can look at a map and see exactly where you want to be. You still have time to plan. You still have time to figure out your photography. And those of you who have questions about using telescope equipment and taking astro imaging, I would encourage you to find out about any astronomy clubs in your area. The North Carolinians, we have really strong astronomy clubs in our state, which is what enables us to do these statewide star parties every year with dozens of events across the state on the same weekend. And if you're in the Triangle area, the Chapel Hill Club is called Chaos, and the Raleigh Astronomy Club is RAC. And the Raleigh Club has got 350 members. So we're crazy strong astronomy community. And these people know so much about that kind of thing. So that was a plug for your local astronomy club. Okay, I know we only
Thanks,
have
Amy.
minutes.
Yeah, we just have a couple minutes left. I did want to squeeze in one of my questions selfishly. Could you talk a little bit about the dark sky movement and, light fixtures and things like that?
Yeah, absolutely. So Your sky, how good it is, depends on the amount of light pollution, not just right where you are, but even in your general area. So for example, Bryce Canyon National Park in southern Utah has detectable light pollution from Las Vegas, which is 4 hours away by car. Light pollution doesn't do anybody any good. It not only messes up your view, your cultural and natural heritage of the sky, keeps you from connecting with it, destroys the time machine effect because you can't see really dim things that are far away. It's not good for astronomy. It's not good for your appreciation of nature. And interestingly, it is not good for many different species, famously sea turtles, birds, fireflies. I could go on and on and on. It messes with predator-prey relationships and reproduction and mating. Fireflies, for example, you know, the male fireflies need to light up to say, hey, look at me, I'm so sexy. And then the females need to light up to say, hey, yeah, baby, I'm in the mood. And when we blitz out their light, that messes up firefly romance. It's also not good for human health. I'm an epidemiologist by training. I've read some of that peer-reviewed scientific literature, epidemiology, the environmental epidemiology literature. It's not just infectious disease. And there's some pretty suggestive evidence that it is not a good idea for humans to be exposed to artificial light at night. And I sleep in a pitch black room because of that research. And it's not good for safety or security either. That's the really ironic thing. People will have these lights that they think are making them safer, but if the light goes straight out, it just creates glare and makes it harder to see. And if it goes up, it's not doing anybody any good at all. So really encourage you all to think about your own use of light and whatever town you live in, its use of light and what kind of lighting ordinances you have. And think about how lights can be shielded so that their light goes down on the ground, which is where we drive and where we walk, and how they can be turned off when they're not being used, put on timers, motion sensors, whatever's appropriate. And if you're interested in learning more, there's an organization called the International Dark Sky Association, darksky.org, and you can learn a whole lot more about light pollution.
Amy, thank you so much for spending the evening with us and sharing your expertise and knowledge and star stories. And really appreciate everybody in our virtual community joining us tonight. Thanks, everybody. Until next time.
Thank you for participating, everyone.
Thanks for coming.